This is Mod 4 Lesson 24 through 25 homework. Okay? This can be found on course. This first one says, the graph of three systems of equations are shown. And it shows you the three graphs. Drag an ordered pair to each box to identify the solution to each system. As we already know, when we're talking about the solution to a system of equations, we're talking about where the two lines intersect. In this case, we're talking linear equations, so we're talking about where the two lines intersect. Okay, so let's see what we've actually got here. Oops. And where do the two lines intersect here? At this point would be at what? 3, -4.5, so 3, -4.5. System A is at 3, -4.5. Where's system B? Where the two lines intersect, which is right here, which would be at what? 3, 0, 3, 0. And system C, where the two lines intersect, which is right here, -4.53, -4.53. Okay, now the second problem. So remember, when you're talking about finding the solution to a system of linear equations, you have three options. You can graph them, and that's what we're looking at right now. You can use substitution. That's when you've got x is equal to or y is equal to. Or you can use elimination. And you have to decide what you're using. Here it says a system of equations is graphed on the coordinate grid below. What is the solution to the system of equations? That's your first thing. Explain how you determined your answer. Well, we know that the solution is where the two lines intersect. So that is at 2, -2. Okay, and how do we find them? The solution is where the two lines intersect. Okay, the solution is the point where the two lines intersect. How about that? Now, the graph below represents a system of equations. Which of the following statements is true? Okay, so they're talking about the solution. Well, the solution's right here, isn't it? This solution's at -4, 3. So the solution of the system is -4, 3. Look at the systems of equations below. Which point represents the solution? Well, this is not plotted for us, okay? So we can't use graphing. The next option is substitution. Remember, if it's substitution, you're going to have x is equal to or y is equal to. We've got y is equal to here, so let's take this y and let's substitute it in for this y, because we know wherever two lines intersect, that point is the same for both of these. So the x and the y is the same value right here where the two lines intersect. So I'm going to plug this in for y. I now have x plus 3 times, okay, in parentheses, let's put this in where the y is. It's like substituting a player in a basketball game. If I put this in for y, y is gone, this is in its place, 3x minus 6. And see, I'm multiplying 3 times everything here, so I've got it in parentheses, is equal to 12. Let's use distributive property. 3 times 3x is 9x. 3 times -6 is -18 is equal to 12. Let's collect like terms here. X plus 9x is 10x. Minus 18 is equal to 12. We're solving for x, so let's add 18 to both sides. We get 10x is equal to 30. Divide both sides by 10. And x is equal to 3. Okay, so we know that our x has got to be 3. This is the only one that has 3 as the x. If you wanted to check yourself, let's find y. To find y, we'd simply plug it in. Y is equal to 3x minus 6. Our x is 3. Y is equal to 3 times 3 minus 6. That would give me y is equal to 9 minus 6, or y is equal to 3. xy is 3, 3. That's what we decided it was. Okay? 5. Which point is the solution to the system of equations below? Well, they're not plotted, although you could get a graph and plot them if you wanted to use graphing. Let's see if we can use substitution. Does either one say x is equal to or y is equal to? They both say y is equal to. So I can substitute this in place of the y. 2x minus 2 then is equal to x plus 2. To solve for the x, we're going to need to subtract x from each side. This gives me x minus 2 is equal to 2. Okay. So now we're going to need to add 2 to both sides, and your x is equal to 4. I only have one of these where your x is 4, but let's go ahead and try and make sure we get the y. Let's plug it in for the y. Y is equal to x plus 2. Y is equal to, and our x is 4. 4 plus 2. Y is equal to 6. Okay, so our solution is 4, 6, right there. Let's go to number 6. What's the solution to the system of equations below? Well, these are not plotted. It'd be tough to plot them because they don't both say y is equal to. Can I use substitution? Does either one say x is equal to or y is equal to? No. But I do have the x's lined up and the y's lined up and the numbers lined up. Okay, there's two things I could do. I could back up and look at this, and I've got 8x minus 3y equals 5, and 8x minus 3y is equal to 11. I know this 8x minus 3y can't be equal to both 5 and 11, so I know that there is no solutions on this. If I'm not sure, here's what I do. I keep going. I say, okay, I'm going to need to eliminate one of these variables. To eliminate them, see, I've got 8 and 8. These are the same coefficients. Why don't I multiply one of these equations by negative 1? I get 8x, because see, that would give me 8x plus negative 8x, so that would eliminate the x. 8x minus 3y equals 5. See, I didn't do anything to the top one. I left it as it was. This one I'm going to multiply everything times negative 1. That's negative 8x. See, and I'm adding this. Don't forget that. Negative 1 times negative 3y is positive 3y. Negative 1 times positive 11 is negative 11. 8x plus negative 8x gives me 0x, so I'll cancel that one. I've eliminated that one. Negative 3y plus positive 3y gives me 0. I've eliminated that one. 5 plus negative 11 is negative 6. Okay, so I've got 0 equals negative 6. That doesn't make sense, so there's no solutions. You're talking about two lines that are parallel and never intersect. Number 7, a system of equations is given below. What's the value of y? They're just looking for the y on this one, right? Okay, well, we don't have it to plot. Nothing says x is equal to or y is equal to, so I can't substitute. The x's are over each other, the y's are over each other, the equals are over each other, and the numbers are over each other. So let's simply eliminate a variable. Okay, none of my coefficients, remember this is a 1 because there's nothing there. 1 and 3 are not the same. 3 and 2 are not the same. I'm going to have to multiply one of these by something to get rid of the other. Notice this, I have 1 and 3 here. What if I multiply everything here by negative 3? Wouldn't that give me a negative 3x plus a positive 3x? If that's the case, then this would be eliminated, wouldn't it? So let's multiply everything here by negative 3. I've got negative 3x, negative 3 times 3y is not positive, but that would be a negative. That would give me a negative 9y. Negative 3 times 15 is negative 45. Okay, and then we're adding. Don't forget, we're always adding if we're trying to do elimination. 3x plus 2y is equal to 10. Negative 3x plus 3x gives me 0. That eliminates the x. Negative 9y plus 2y gives me negative 7y. Negative 35 plus 10 gives me negative 35. Negative 45 plus 10 gives me negative 35. Divide both sides by negative 7. and our y becomes negative divided by negative is a positive. Y is 5. There's your answer. Let's go to the next one, number 8. Drag the solution to each system of equations into the appropriate box. Okay, so I need to solve this one. Okay, neither one of these says x is equal to or y is equal to, so let's come over here and see what we can do to eliminate a variable. Okay, I understand that there's a positive 1 in front of each of these, so what if I've got to add these, what if I multiply one of these by a negative 1? That way I'd have a negative 1 plus a positive 1. Okay, that would get rid of it. So let's do this. It gives me negative 1x, a negative 1 times 1/2 is negative 1/2 y. Negative 1 times 3, you give me negative 3. Now let's add this other one. I've got 1x plus y, that's 1y, right? If there's nothing in front of it, equals 5. Negative 1x plus 1x is 0. That eliminates that variable. That's 0. Okay. Negative 1/2 plus 1 gives me 1/2 y is equal to 2. Okay. That being the case, guys, what do? I'd multiply by the reciprocal. The reciprocal of 1/2 is 2. And y would be equal to 2 times 2 is 4. So I'm looking for one of these answers that's got 4 for the y. There's a couple of them, so let's find out what the x is. How about if I use one of these equations? X plus y equals 5. X plus 4 is equal to 5. Subtract both sides by 4. And x is equal to 1. So we're dealing with 1, 4. Okay, our solution would be 1, 4. Did we have one of those down there? Yes, we did. Okay, now let's try solving this one. Do I have x is equal to or y is equal to? Yes, I do. I have y is equal to. So can I substitute this in place of y? So I'm going to use substitution instead of elimination. 2x plus 2 is equal to 4x plus 1. Okay. I'm going to subtract 4x from each side. I've got negative 2x plus 2 is equal to 1. I'm going to subtract 2 from each side. I've got negative 2x is equal to negative 1. Let's divide both sides by negative 2. X is equal to negative 1 over negative 2, which is 1/2. So our x is 1/2. We've got several with x is 1/2. We need to find our y, don't we? Okay, let's choose one of those equations. Y is equal to 2x plus 2. Y is equal to 2x plus 2. And if our x is 1/2, y is equal to 2 times 1/2 plus 2. 2 times 1/2 is 2/2, which is 1, plus 2, so y is equal to 3. This coordinates would be 1/2 and 3, okay? And we've got a 1/2 and 3, 1/2 and 3, okay? Let's go to the next one. This is number 9. What is the y value of the solution to the system of linear equations shown below? Well, we could get graph paper and do this, but there's a big number here. Let's see about substitution. Does either of them say x is equal to or y is equal to? Oh, these both say y is equal to. So I can substitute this in place of the y, can't I? 2x minus 6 is equal to 5x minus 21. All right? How about if I subtract 5x from both sides? I get negative 3x minus 6 is equal to negative 21. Let's add 6 to both sides. Negative 3x is equal to negative 15. Divide both sides by negative 3. And x is equal to 5. Okay, we got x, but I need y, don't I? Let's plug it in for one of these. y is equal to 2x minus 6. So y is equal to 2 times 5 minus 6. 10 minus 6, which is 4. There's your y. Remember, this is the trick is you think you got it when you got the x, but they ask you for the y value, right? Okay. Let's look at this one. The graph of 2x plus y is equal to 8 is shown. Graph this equation on the same plane. Plot the point that represents the solution. Okay, so let's graph this one. Remember, for graphing, it's y is equal to mx plus b. We'd start at negative 6. Okay, so we'd start at negative 6 on our chart. And then where are we going? Our slope is 1/3. That means that we are going rise over run, which is 1/3, up 1/3 for each one of these. Okay. Up 1 over 1, 2, 3. Up 1 over 1, 2, 3. This is where these two lines would intersect. Would be right there. Okay, what point is that at? That's at 6, -4. And we put our dot there. Which is true about the system of equations below. Okay, well, we're going to have to figure out what we've got. I could look at this and say, if I multiply, look, there's a lot of things. If I multiply this by 3, this 2a by 3, I get 6a. This by 3, I get -3b. This by 3, I get -12. So I suspect these are the exact same equation. But if I'm not sure, let's solve this. Now, we don't have x is equal to or y is equal to, so we're going to have to add these two. I need to get rid of one of these variables. This is a -3, and this is a 1. So if I multiply this here by -3, wouldn't that give me positive 3b here? Let's see, 6a minus 3b equals -12, because I'm trying to get rid of one of these variables. And I multiply everything here. -3 times 2a would give me -6a. -3 times -1b would give me a positive 3b. -3 times -4 would give me a positive 12. Well, let's look at C. -6a plus 6a plus a -6a gives me 0. -3b plus 3b gives me a 0. Okay, so I've gotten rid of both of them. It's just 0 on the side. -12 plus 12 gives me 0. If 0 is equal to 0, we are talking about two equations that are exactly the same. They're right on top of each other. Okay? So all of their points are exactly the same. It is infinitely many solutions. Find the exact solution to the system of equations below. Show your work and explain your steps. Well, let's think about this. I can't really plot it. Neither one says x is equal to or y is equal to. So we're going to have to use, we're going to have to eliminate a variable. We're going to have to use elimination. The x's are over each other, the y's are each over the equals and the ones. Okay. Let's see what we can do to get rid of one of these variables. I've got a 1 here. If I multiply everything here by -2, that will give me a 2x plus a -2x. 2x minus y equals 1. -2 times 1x is -2x. -2 times 1/2 is -2/2, which is -1. So that's -1y. That's -1, right? -2 times 1 would give me a -2, right? Okay. -2x plus 2x plus -2x is 0. You've eliminated this variable, right? -1y plus -1y is -2y. And 1 plus -2 gives me -1. divide both sides by -2, and I've got y is 1/2. They wanted the solution. We know a solution is where the two lines intersect. So I've got y is 1/2. I need to find the x, don't I? To find the x, I need to plug it in. Plug it into either one. How about this? 2x minus y equals 1. Okay, 2x minus 1/2 is equal to 1. All right, so 2x, we're going to add, let's add 1/2 to both sides. I've got 2x is equal to 1 and 1/2. 2 to 1 is 2 plus 1 is 3. This is 3/2. 2x is equal to 3/2. Now, let's divide both sides by 2. If I divide this by 2, same as multiplying by 1/2. X in is equal to 4. 2 times 2 is 4. Okay, I'm sorry. 3 times 1 is 3. 2 times 2 is 4. That would be 3/4. Okay, 1/2, 3/4. Let's look at number 13. System of equations is shown below. What's the solution to this system of equations? Let me look at something real quick on this one. 1/2 and 3/4. Let's see if that works. 2 times your x is 3/4. Okay, I'm checking myself. Minus my y, which is 1/2, and let's see if that's equal to 1. 2 times 3 is 6/4. Minus 1/2 equals 1. Okay, that would be 6/4 minus 2/4 would be equal to 1. That's 4/4. So yes, that works, doesn't it? Okay, I just wanted to check myself. Let's go to 13. A system of equations is shown below. What's the solution? Well, let's look at this, guys. If I multiply everything here by 2, I've got 8x, -2y, -4. I think we're going to have this such that they're exact same solution, and we're going to have an infinite number of solutions. But let's check and see. We're going to try for elimination. Let's look at our coefficients. I have a -2 here and a -1 there. If I multiply everything here by -2, then that should give me -2y plus 2y. So let's try. 8x minus 2y equals -4. -2 times 4 would give me, see we're adding, -8x. -2 times -1 is positive 2y. -2 times -2 is positive 4. 8x plus -8x is 0, so that eliminates that. -2y plus 2y is 0, that eliminates that. So we got to have something here. It's a 0, right? -4 plus 4 gives me 0. 0 is equal to 0. What we're looking at is a situation where these two equations are exactly the same. Okay, so there's an infinite number of solutions. The system of equations is shown below. What's the value of y for the solution? So we're looking for y, not x, y. Can we plug this in? Do we have a substitution situation? X is equal to or y is equal to? No. Now guys, we want y. So we could get rid of either variable. Why don't I get rid of x if I'm trying to get to y? Remember, if you're doing elimination, you're adding. So I've got 2x here plus 1x. Now I need this to be -2x. So let's multiply by -2. Everything here. That gives me 2x minus 1y equals 3. -2 times 1x is -2x. -2 times -3y is 6y. -2 times 4 is -8. -2x plus -2x is 0. That's eliminated. The x is eliminated. See, I'm looking for my y. -1y plus 6y gives me 5y. 3 plus -8 is -5. Divide both sides by 5. Y is equal to -1. Okay. Now let's go to 15. What's the solution to the system below? Well, neither says x is equal to or y is equal to, so I'm going to have to use elimination. That means I'll be adding the two variables. I need to find a way to get rid of one of these variables. Ooh, I shouldn't have given y'all one of these. I'll show you how to do it, guys, but you probably won't encounter something like this on my test. When I'm dealing with a coefficient that I can't easily multiply something by, I can multiply this one by -3 and this one by +5, and it will work. Okay? -3 times 5 is -15x. -3 times 6 is -18y. -3 times 14. See, 4 times 3 is 12. That's 3. -3, that's -42. 5 times 3 is 15x. 5 times 5 is 25y. 5 times 7 is 35. -15x plus 15x is 0, so that's gone. -18y plus 25y is 7y is equal to -45 plus 32, which gives me -7. Divide both sides by 7, and you get y is equal to -1. Look, I only have one answer that's got -1 for the y. All right? What's the solution for these? Well, we know if there's nothing there, there's an understood 1 in front, right? Look, I have a -1y, and I have a -1y. If you added those two, which you're going to have to because nothing says x is equal to and nothing says y is equal to, and we're going to have to use elimination. If I multiply everything here by -1, then I'd have a -1y plus a +1y, and the y would be gone. So 2x minus y equals -4, plus -1 times -3 would give me 3x. -1 times -1 is a +1y. -1 times 2 is -2. 2x plus 3y, through x plus 3x is 5x. -y plus +y, y is gone. Eliminate the y. -4 plus -2 is -6. Divide both sides by 5. And x would be equal to -6/5. Okay? This is the only one that's got a -6/5 for the x. Enter the coordinates for the solution to the following system of equations. Well, both of these say y is equal to, so I can use substitution. I can substitute this in for y. 3x minus 8 equals -x minus 4. I'm going to add x to both sides. I've got 4x minus 8 equals -4. I'm going to add 8 to both sides. I'm going to get 4x is equal to 4. Let's divide both sides by 4, and x is equal to 1. Now, how do we find y? Plug it into either equation. Y is equal to 3x minus 8. That'd be y is equal to 3 times 1 minus 8. Y is equal to 3 minus 8. Y is equal to -5. And then the last one. What is the solution to this system of linear equations? Well, we've got 2x plus 3y is 40. We've got y is equal to, we've got an x is equal to or a y is equal to, so I could use substitution. I'm going to substitute this in place of the y here. 2x plus 3 times, and in place of this y, I'm going to put x plus 10 is equal to 40. 2x plus 3x plus 30 equals 40. Collect your like terms. 2x plus 3x is 5x plus 30 equals 40. Subtract 30 from each side, and I get 5x is equal to 10. Divide both sides by 5. X is equal to 2. There's only one of these that says x is equal to 2. And that's the end of the homework.